Today we're going to talk about a new term called Sigma notation. And then we're going to talk about another vocabulary word here, arithmetic series. So first of all, when the terms of a sequence are added together, sometimes we just take them all, a list of numbers, and add them up in a sequence. It's called a series. I think I'll write in black pen, blue pen. It's called a series. So when you add the numbers, you get a series. Summation notation. Well, that's a phrase. That's interesting. This is also called sigma notation. Is used to write a series. Now this little symbol right here, it looks like an E. It is an uppercase Greek letter. And this Greek letter is called sigma. And it's an uppercase sigma. We're going to be learning about a lowercase sigma later on this year, but this is uppercase sigma. So what does an uppercase sigma do for us? First of all, what we're going to do is we're going to have the letter sigma. This is just a Greek letter. And around this sigma, we're going to have some numbers and some letters. So down on the bottom, we have a letter. In this case, it's N. We usually use N, but you don't have to. You can use any letter you want, like an I or a J or a K or anything you want. But this value is the index. And the index starts at some integer, which is called the lower bound. This number is lower than this number. This is the upper bound. This is where you start the sigma. This is where you stop at the upper bound. And then over here you have an expression. And this expression has a variable in it usually. And if it has a variable, it has to match this letter, has to match this letter. N is called the index, and this expression is what you're going to be evaluating with the numbers that this index is going to be. So what do you do with a sigma? Sigma means add a whole bunch of numbers together. And when you add a whole bunch of numbers together, it's called expanding sigma notation. In order to expand sigma notation, you have to substitute the n value for whatever the lower bound is. Oftentimes it starts at 1, but it doesn't have to. So you start this n value at 1. Then you increase n by 1. So you would increase this by 1, so you'd bump it up to 2. And then you're going to substitute in for n into the expression, bump it up by 1, substitute in, bump it up by 1 until you reach up what the upper bound is. So you're going to make a whole bunch of substitutions into this expression with the numbers 1, 2, 3, and 4. So n goes from 1 to 4, and you increase up by 1. So what does all this really mean in this case? Well, if you want to expand this sigma notation, this is exactly the same as this. You're going to start out with n equals 1. So when n equals 1, you have 2 times 1, 2n. So n gets substituted in here, 2 times 1, and you write it down. Then you're going to add to this, because this is sigma. Sigma means add. And then you're going to bump n up by 1. So n goes from 1 to 2. Then you're going to add to this. This n gets bumped up by 1 and becomes a 3. Then you're going to add to this. This n value gets bumped up by 1 and it becomes a 4. So those n values start at 1, then goes to 2, then 3, and 4, and that's where you stop, because the upper bound is the stopping number. So what you're going to do now is you're going to add 2 plus 4 plus 6 plus 8. And when you add those together, 2 plus 4 plus 6 plus 8, you're going to get the number 20 out of it. Here's another example of a sigma. In this example, I'm using another letter called J. And I'm not starting at 1, I'm starting at 5. So the J numbers are going to be going from 5 to 6 to 7 to 8 to 9. And they're going to be replaced in this J here. So you're going to start at J equals 5. So it's going to be 5 times 5 plus 3. And then j gets bumped up from 5 to 6. And then j gets bumped up from 6 to 7. J gets bumped up from 7 to 8. And j gets bumped up from 8 to 9. And when you get up to 9, that is where the stopping j value is. Stop at j equals 9 because that's the upper bound. Right here, I should probably add right here, stop at n equals 4 because that's the upper bound. You start at n equals 1, you stop at n equals 4. In this example, you start at j equals 5 and you stop at j equals 9, and you bump the j up by 1 every time. So what we have is 5 times 5 plus 3. So that's 25 plus 3 is 28. So here's your first term. Then you're going to add to that 5 times 6 plus 3, 5j plus 3. Well, that's 30 plus 3, which is 33. Then you're going to add to this 5 plus 7, 5 times 7 plus 3. 35 and 3 is 38. Then you're going to add to that 5 times 8 plus 3, 8 plus 3, which is 43. And you're going to add to that 5 times 9 plus 3, which is 48. And so we really have a sequence of numbers here, 28, 33, 38, 43, 48. You can see that pattern. And we're going to just add them all together. So when you add them all up, you will see, if you do it in your calculator or try to do it by hand, you'll see that the number is equal to 190. So this is the sum of the terms. There are 5 terms between 5 and 9. And they're all added together. So we have some more examples to go by here. So we're going to write each series as the sum of terms first. So we're going to add them up like this, and then we're going to compute in the end. So this letter is the letter K now. We're going to use K instead of N or J. It really doesn't matter what letter you use. So the sum of terms. Well, first of all, you're going to let K equal 3. So it's 2 times 3 plus 1. There's the first term. 2 times 3 is 6 plus 1 is 7. So there's your first term. Now you're going to add to that. K gets bumped up by 1. So it's 2 times 4 plus 1. K goes from 3 to 4. Well, 2 times 4 is 8 plus 1 is 9. So first term, second term. Add to that, now K gets bumped up by 1. 2 times 5 plus 1. K goes from 4 to 5. 2 times 5 is 10 and 1 is 11. Then you're going to add to that 2 times 6 plus 1 because K gets bumped up from 2 to 6. 2 times 6 is 12 and 1 is 13. So there are your sum of terms. And you're going to stop at K equals 6. Stop here, because the sigma notation tells us to stop here. Start at k equals 3, stop at k equals 6. So let's see, 7 and 9 is 16. 16 and 11 is 27. 27 and 13 is 40, I believe. The next example, we're going to start at n equals 1. So we're going to substitute n equals 1 in here, so it's 1 squared minus 1. There's your first term. 1 squared is 1, and 1 minus 1 is 0. Then you're going to add to that, you're going to bump n up by 1, and it becomes 2 squared minus 1. Well, 2 squared is 4, 4 minus 1 is 3. So there's your second term. Then you're going to bump n up by 1, and you get 3 squared minus 1. 3 squared is 9, minus 1 is 8. Now you're going to bump up n up by 1. 4 squared minus 1. Well, 4 squared is 16, minus 1 is 15. And now you're going to bump n up by one more time, and it's 5 squared minus 1. 25 minus 1 is 24. You're going to stop at n equals 5. You're going to start at n equals 1. Stop at n equals 5, and n gets bumped up to 1, 2, 3, 4, and 5. So now we're going to add these up. 3 and 8 is 11. 11 and 15 is 26. 26 and 24, I believe, is 50. Next, now we have to write in sigma notation. Now this is a little bit trickier. Well, if you write it in sigma notation, you have to write a sigma. So there is your sigma first of all. Then you're going to decide what letter to use as an index. It doesn't matter what letter you use. Let's say we're going to use the letter N. Now this, if you notice this notation, this goes up 5, plus 4 is 9, plus 4 is 13, plus 4 is 17, plus 21, plus 4 is 21. So this goes up by 4 for each term. So that makes this, if you had 5, 9, 13, and 17, this makes it arithmetic, like an arithmetic sequence. And if you remember the formula, AN equals A1 plus D times N minus 1, that's how you get all of the terms in an arithmetic sequence. So this AN is going to go here as our formula. So the formula to get those numbers is A1, the first term is 5. The difference between all these terms is 4. And you distribute the 4, 4n minus 4, and then you combine like terms. So 5 minus 4 is 1, 4n minus 1. So that's the formula for this arithmetic series. So we're going to put a 4n minus 1. And the n starts at 1. How many terms do we have? 1, 2, 3, 4, 5 terms. So these are the n values here. It starts at 1 and it ends at 5 because we have 5 terms. And that's how you write the sigma notation. Now this particular one has a numerator and a denominator that are both arithmetic. So 3, 4, 5, 6, 7, these d values are equal to 1 because there's a difference of 1 between them all. And down here, these d values are also equal to 1, 4, 5, 6, 7, 8, 9, 10. So if you wanted to set this up as an arithmetic series, you could, but it's a little bit easier to say, well, I'm going to add all these numbers. These numbers start at 3 and end at 9. So we can say, oh, n is equal to 3. And how many terms do we have? 1, 2, 3, 4, 5, 6. Well, it starts at 3 and it ends at 9. So what we have on the top is just the n values. N equals 3, n equals 4, n equals 5, 6, 7, 8, 9. Now what do we have in the bottom? If n equals 3, n equals 4, n equals 5, n equals 6, n equals 7, 8, and 9, if you have that, then how do you get from a 3 to a 4? You just add 1 to all those n values. So this would expand out 3 over 4 plus 4 over 5 plus 5 over 6 plus 6, and it would expand out to be that. There are many, many different answers to this sigma notation. Here's another thought. Another answer could be, maybe we want n to start at 4 and end at 10. That's okay also. And in the bottom we have an n because n goes from 4, 5, 6, 7, 8. And then how do we get back here? We have n minus 1 because you just subtract 1 and you'll get to the numerators. So there are an infinite number of correct answers to number 4. These are just 2 of the most common ones. Or if you wanted to set it up like this, if with an arithmetic series, you could do that, but it requires a little bit more work. You can use a calculator to figure out what this answer is going to be. We didn't want to get the answer, we just wanted to write it in sigma notation. But if you want to use the calculator, let me show you the buttons that you can press. I'll zoom out here a little bit. You can press alpha. This tells you alpha window option 2. So alpha window, you can see the little sigma right there, option 2. So this says you can let any number be your index. I like to let it be x because then you just have to press this x button. And let's go up here. Let's do one of these that we've already done. Let's say x equals 1 up to 4. And now we have a 2. Instead of a 2n, we're using a 2x because that's our index. You can use anything you want here. So when we put that in, it's not going to show us the sum of terms, but it's going to give us a 20, which is the final answer here. In this next example, if you do alpha window option 2, and now we're going to let x equal 5 up to 9, and the formula was 5, I'll call it 5x plus 3. That should give us 190. So you can get the answer in the end to this. You just can't see what all of the sum of the terms are. But I just wanted to show you that you can use the calculator on Sigma. Now if you add all of the terms of an arithmetic sequence, it's called an arithmetic series. Now sometimes you have to just sum the first 10 terms or the first 20 terms or the first 30 terms, the first n terms of an arithmetic series, sequence. If you want to sum the first n terms, there's a formula that you can use. This means S stands for sum. The first n terms, so like if you want to sum the first 20 terms, you do S20 equals 20 times the first term plus the 20th term all over 2. You don't have to memorize this. It's on a reference sheet that you'll get every time you take an exam. So if you want to use this formula, you have to know the first term and the nth term. And then you can plug it into the formula. If you don't know the first or the nth term, you can use that famous formula that we used last time, an equals a1 plus d times n minus 1, to calculate whatever you don't have. So here are some examples. Here's an arithmetic sequence. 4, 8, 12, 16. What you're doing is you're adding 4 plus 4 plus 4 plus 4. So if you're adding 4, so the d value is equal to 4. The first term is equal to 4 also. And I want to sum the first 20 terms. So 20 means n is 20. 20 means how many terms we're summing. So that's the first step. Write out what d, a, and n are. Okay, now we have to figure out what the nth or the 20th term is. So the 20th term is equal to the first term, 4, plus d, which is 4, times n, which is 20, minus 1, right? Here's the formula. We know the first term, we know d, and we know n. So we're going to find the 20th term. So this is equal to 4 plus 4 times 19, which is equal to 80, I believe. 4 plus 4 times 19 is 80. So the 20th term is equal to 80. So that's the second step. Now we're going to use this formula up here. S20 is equal to 20 times the first term plus the 20th term all over 2. So the sum of the first 20 terms is 20 times the first term, 4, plus the 20th term, 80, all over 2. So let's just use our little calculator here, make sure we're going to be right. So 20 times 4 plus 80 all over 2 is 840. So that's our answer. That's the sum of the first 20 terms. All right, here's our second example. We have to go up by 10. Plus 10, plus 10, plus 10, plus 10, so the d value equals 10. The first term is equal to 6, and we are summing the first 20 terms in all of these cases, so n is 20 always. So our first step is done. Our second step says let's find the 20th term. The 20th term is equal to the first term plus d times n minus 1. Oops, d is 10, sorry. So 6 plus 20 minus 1 is 19. 19 times 10 is 190. So the A20, the 20th term, is equal to 196. So now we want to get the sum of the first 20 terms. And we're going to use this formula up here again. So n, which is 20, times the first term, which is 6, plus the 20th term, which is 196, all over 2. So the sum of the first 20 terms is 20 over 2 is 10. 6 plus 196 is 202. I think that is 2020. Let me just make sure. 20 times 6 plus 196, 2020. All right. Now we know the fourth term and we know d. So we've gotten the d written out. We know n is 20, but we don't know what a1 is. So we know the fourth term. Let's see if we can get down to the first term. If d is -2, then you're going to add 2 to get up to the previous. So 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, right? If you want to go from the first up to the fourth, you have to keep subtracting 2, but if you want to get from the fourth down to the first, you have to keep adding. So you have A1, the first term. So the sum of the first 20 terms is equal to n, which is 20, times the first term, which is 8, plus the 20th term. Oh, we don't know the 20th term yet. Let's figure it out. The 20th term is equal to the first term, which is 8, plus d, whoops, that should be a minus because d is negative, minus 2 times 20 minus 1. So 8 minus 2 times 19 is -30. So the 20th term is equal to -30. So we have 20 times 8 plus -30 all over 2. And this is -22. So -22, 0, I believe. Let me check. 20 times 8 plus -30 is -220. And then we have the third term and the d value this time. So we have to find the first term. What's the first term? So now we're going to be subtracting 3 to get to the next one. So 13 minus 3 is 10, minus 3 is 7. So we have the first, we need to find the 20th, is the first term plus d times, whoops, d is 3, n is 20. So 7 plus 3 times 19 is 64. So we have the 20th term. So now the sum of the first 20 terms is equal to n times the first term, which is 7, plus the 20th term, which is 64, all over 2. See, 7 and 64 is 71, 710, I believe. Seven plus 64 over 2 is 710. Yep, And that's it for today.